So let's look at part B of exercise 2 on page 28. We are on page 28 here. I wrote down the answers to part A, but let's work through part B and then we'll talk about both of those together for a little bit. So in part B, we have the group of integers under addition, and we are asked to find the center of this group of the integers and then also the centralizer of the element 1 and the centralizer of the element 2. Okay, so we know addition, integers under addition very well. So I ask you, when you are adding two numbers, which of those commute? So for which numbers is a plus b equal to b plus a? For what integers? Well, the integers, addition in the integers is commutative, so this is actually true for everything in Z. So the center of Z is all of Z, because it doesn't matter which integers you take. You take 1, it commutes with everything. You take 2, it commutes with everything. You take 3, it commutes with everything. So the center of Z is Z itself. What about the centralizer of an element? So now I'm just taking 1 and I want to know what are all the elements that commute with 1. 2, 3, 4, minus 1, minus 2, minus 3. That's also all of Z. And what about the centralizer of 2? What are all the integers that commute with 2? That is also all of Z. Now, what is special about Z? Why was the answer Z to all of these things? Well, because Z itself is an abelian group. So this is true because Z under addition is abelian. So we have the commutative property in Z under addition. All elements commute with all other elements. So you could generalize this. Our argument wasn't that specific to Z, to the integers. You could say that if you have an abelian group in general, then your center is the group itself. So this is true for all abelian groups. So that is nice. So we said that the center and the centralizer, both types of subsets of a group, are subgroups themselves. And in exercise 3, you're actually going to prove that. So I highly recommend that you work through that exercise and then you can compare with the solution. One thing that you may want to also think about a little bit more is just what can you say about subsets of abelian groups? So you can also think a little bit more about abelian groups. So if you have an abelian group, what do you think can you say about subsets of abelian groups? When you have a non-abelian group, like we saw in D4, what can you say about subsets of non-abelian groups? Is it true that are some of them abelian? Are all of them non-abelian? Are some of them non-abelian? So try to think about that a little bit. This is a good point to think about that. And you can also read in our book a little bit more about it. And some of the questions in the video quiz are also asking about those things to give you a chance to just ponder those questions a little bit more.